Welcome back at MX-5 Info at part 2 of the series on how to install air conditioning on the NB2. If you missed part 1, then I recommend you to watch that video as well and to subscribe to the channel. In this episode we will look at the quality of the individual parts and we'll verify them to see if they are good enough to go onto the car. This is the AC switch with its original connector. This one will go into the HVAC panel to switch on or off the AC. It's powered by the AC fuse. And we can run two tests. One is to test for continuity between pins A and B. If the switch is in the on position, and no continuity when the switch is in the off position. And then we'll run a test to see if the LED that's located in front here in the switch, if that still works. Then we supply 12 volt to the pink wire and ground to the blue yellow wire. So let's do that. I will first hook up the pin A, then pin B. There's no continuity at the moment. If I use the switch, then you can see there's continuity. Switch it off, no continuity. Continuity, no continuity. Then for the second test, I can connect this lead to the pink wire and move it over to the battery. 12 volts there. Ground over here. Currently there's no light. And when we switch on, there's light. So this switch is fine. The AC system uses two of these H270 relays in the engine bay. One will be used for the AC compressor, for the magnetic clutch, and the other one is used for the condenser fan. If we want to test these relays, we need to understand the pinout. Mazda names their pins. The right top is A, underneath B, left top C, underneath D. In this case we have a clear split in low power and high power. So the low power wires will control the relay, activate the coil or not, and the high power side is the side where a wire directly from a fuse with 12 volt will be only connected to the outgoing wire towards the magnetic clutch or the fan when the coil is switched. So at the moment we don't have any connectivity between the wires C and D. That will only happen when this relay is switched. To switch this relay we need power from the AC fuse going to pin A, and then pin B will be switched by the ECU. So the ECU decides whether it is safe or not to activate the magnetic clutch or the condenser fan. So I've wired up this blue wire to battery positive, and the green wire will go to battery negative if I want to switch the relay. So when I want to switch the relay, I need to ground that wire like so. You can hear the relay click. And when it's active, you can also see that there's continuity over the relay. So in this case, power would go to the compressor or to the condenser fan. So this relay is okay. This is the condenser fan, the one that will go next to the normal cooling fan on the radiator. Again, I've used an original connector to make it easier to hook up a battery. Battery plus is already connected. When I connect battery minus, then the fan should spin. Which it does. So this is an easy test. This fan is ready to go onto the car. This is our compressor. We can run a few quick tests on this one. This is the pulley that should drive the compressor. At the moment it can spin freely. That's good. The main shaft of the compressor can be turned by hand, and then you see that this pulley is not going anywhere unless the magnetic clutch is activated, which you do through a plus here and the ground through the housing of the compressor. So when I activate that coil and the magnetic clutch, then we can see that these two spin together. So that's how it is belt driven. If you watch closely, then you could see a small gap in between here. It's about 0.5 millimeter, and that gap will close. The other wire over here, this is to activate the coil. There's a thermal security in here, so when the compressor would overheat, it would no longer engage. And basically that's it for the moment. These contact surfaces should be cleaned very well, because this is where the refrigerant lines go in with an O-ring. And if these surfaces are not clean, then it basically increases the distance and the chances for leakage. For the test of the thermal switch, we have a lot going on at the same time. I have some ice water here. This is a temperature sensor. As you can see, the temperature is rising now, 5, 6, 7 degrees. Trying to correct it. When I put it in the ice water, it will go back to 0 degrees. Because this thermal switch is used to protect the evaporator from freezing. It currently has continuity, and that is because the temperature here on the table is sufficient. But when the temperature drops below 3.6 degrees, which will happen when I put this into water, then you will see that it will lose continuity at some point. And that's when the AC will switch off, which just happened. You can see now it's measuring an open connection. If I take it out of the water again, then it should restore itself and provide continuity again. Might take some time, and there it is. It has detected that there's no risk for a freezing evaporator. This thermal switch is okay. This is the pressure sensor in the high pressure lines from the condenser towards the evaporator. At the moment we can only test if this sensor shows no continuity, because when there's no pressure in the system it should show no continuity. When there is pressure on the system, then there should be continuity. And this is how the ECU is informed about the fact whether there's sufficient pressure on the refrigerant lines or not. You are currently looking at the condenser and some of the refrigerant lines. For the condenser, mainly we can do a visual inspection on both sides. We can make sure that this is clean. If there are any damaged parts, fins, you can correct those with a screwdriver if it's not too big, or with a pick. You could also use that to correct some damages. And other than that, you can make it part of the inspection where you try to test if the system holds vacuum, or if you have the equipment, do also the pressure test with nitrogen at a higher pressure. For the evaporator, it's basically the same story as for the condenser. You can clean it, inspect it for damaged fins and correct those if you like. There's always a bit of a bigger opening around this area because this is where the temperature sensor goes in. It's done in this way. And this is outside of the housing. So no need to correct for that gap. The next step in the process could be to do a vacuum test, and therefore you would need some equipment like a vacuum pump and the gauges and lines that go with it. On the condenser you will have this high pressure connection, and near the pressure sensor you have the low pressure connection. So I will hook those up and try to get a vacuum on this complete system. Everything is connected now. You can hear the vacuum pump running. You can have a look at the gauges over here, and you can see that indeed we are pulling some vacuum. I will have this continue for a while, and then when I stop the pump, we need to monitor if the vacuum stays. Thanks for watching MX-5 Info. Please don't forget to like and subscribe. That way you will be automatically notified when part 3 is ready in this series. If you have any questions or remarks, please leave them in the comment section below.